Recording in your journal today on page 81, just a reminder, you should have glued in 2 pages on the last 2. So we're on page 81, should be on the right-hand side. We'll be doing volume of pyramids, P-Y-R-A-M-I, volume of pyramids. And this is 8-7, lesson 8-7. And when you think of pyramids, we think of Egyptian pyramids, because Egypt and those pictures you've seen probably in different textbooks or in different pictures over the years refers to what you think of in your head as an Egyptian pyramid. So we're going to be looking at pyramids, and here's a pyramid example right here. And a pyramid is a three-dimensional shape. It's 3D again, with one base, and it has triangular lateral faces. So when we were dealing with rectangular prisms, the rectangles were all the way around on all the sides. When we dealt with a triangular prism, we had triangular bases, but all the faces were rectangles going around. If you take a look at all the shapes going around, it does come to a point. Hence, it's a pyramid. It's coming to a point, and it's made of triangles. And that's the only way we get that point is by putting the tops of the triangles together. We are going to be applying a formula, and it's found in your formula chart. And again, it's volume equals big BH, only this time it's a third. And if you have a chance to be with me in class, I'm going to try to show you guys how this became about to be a third of the volume of a rectangular prism, because rectangular and triangular prisms really pretty much have big BH, while triangular is 1/2 the base. But in the case of the volume of a pyramid or any pyramid, it's 1/3 the area of the base times the height. And again, the B is dependent on whether it's a rectangle or a triangle, and that's why I said the 1/2 for the triangle, but it's not half for the rectangle. So if you look at the formula here applied, the base figure is a square, well, actually a rectangle, because the dimensions are different. And so you apply 1/3. So because it comes to a point, there's only a third of the volume of what a rectangular prism would be of the exact same dimensions. And so we're going to do 1/3. And if you notice the LW here, that's referring to the big B. And again, the big B is the area of the base figure. And some people are still having problems with that, I'm sure, but we got to get that in our heads. And then times the height. So this isn't going to go away. You'll do this again in 8th grade and all through high school, so get used to it. So we got 1/3. The length is 4 3/10 right here. The width is 3 2/10. That's of our base. And our base will be the shape that is not the triangles going up to a point. And that's just a good way to remember which one the base. There should only be one base. There's only one base on any pyramid in the world. There's only one base. And it's going to be, it doesn't have to be sitting on it. It can be sitting on a side, but most of the times they're sitting on their bases. And then, of course, we have the height, which is how tall it is as it's holding up, kind of like the tent pole, and it's holding it up and it's going up to the top of the tent. And so that is our height. And then we're going to just apply our mathematical skills. You can take a third of 4.3, you can take a third of 3.2, or you can multiply these two numbers and divide by 3 and then multiply by 11, or you can multiply all these numbers and then divide your final answer by 3. So there's a lot of possibilities on how you want to do it. But the volume is going to be 50 5/10 cubic meters. And a reminder, when it says cubic meters, it just looks like this. Meters to the 3rd power. 3 dimensions, 3D. So take a look at the 3 shapes we're going to do. We're going to work these out mathematically. But you do have to ask yourself, just like with the prisms, is it a rectangular prism? Is it a triangular prism? Is it a rectangular pyramid or a triangular pyramid? And so we take a look at the base down here and we say, oh, okay, that's a rectangular pyramid. And the reason I know it's a pyramid is because all the faces are triangles and it comes to a point at the top. The base itself is a rectangle, hence the name rectangular pyramid. And so these are just some things you got to know and how to name it, rectangular pyramid. And so I'm going to apply the formula volume equals 1/3 big BH. So we don't have just big BH, we have 1/3 big BH. And so I'm going to say, okay, volume equals 1/3. The base figure is a rectangle. The area of a rectangle is length times width. And then I'm going to have times height. So if you notice, I'm just substituting for B. I'm just going to exchange B for what I know the base to be is a rectangle. So it's length times width. So that's 1/3 the length, which is 8, times the width, which is 7, and then multiplying by the height, which is where the tent pole is. If you picture that as a tent pole, would be 6. So once it's all multiplication, it doesn't matter what order I do this in, but I can go ahead and take 1/3 of 6 because I know 3 goes into 6, and I'm just going to do it like this 2 times. Woohoo! And I'm going to say, okay, let's see, 8 times 7, that's 56. Some of you don't know that. We got to get your math skills down. So 56 doubled. So that's 56 times 2. We'll do a little math over here to the side. 10 and 1 is 11. And I get 112 centimeters cubed. That's the volume of that pyramid. It is a rectangular pyramid named by its base shape. Take a look at number 2. This rectangular pyramid is sitting on its side. If you don't like it and you want to put it on its base, all you have to do is rotate the page, and you can work the problem that way if you want. It doesn't matter to me. Okay, I'm going to turn this back though, just to make sure we understand what we're doing. I know that this is going to be a base figure right here where it's making a 90-degree angle with the height. That's my base. And so I'm going to call this a rectangular because the bottom is a rectangle. Rectangular pyramid. So back to why it's a rectangular pyramid, because it only has one base. It's opposite the point. So it'll be opposite that 90-degree angle there. And it's a rectangle. Okay, so we're going to do volume equals 1/3 big BH, which means we're going to do 1/3. The base figure is length times width. That's the area of a rectangle times height. So we got 1/3 the length, 7 the width, 2 and 3/10. Make that sure that looks like a decimal. Times the height of 10. So you can multiply these in any order that you possibly want. Actually, I think I'm going to do 7 times 10, which is 70. Okay, that makes it a little bit easier. I'm going to do this in little bits and pieces. Some of you try to jump the gun and do it all at once. It's completely up to you. I kind of like to break it down. So I'm going to do 70, and I'm going to do times 2 and 3/10. And I'm going to put the 2 and 3/10 on the top because I want to ignore the zeros. So I'm going to ignore the 0. Well, I can go ahead and do the 0. 0, 0, hug, kiss. 21, 14, and 2 is 16. 0, 1, 6, 1, and move my decimal one place. Now I could have just multiplied the 7 times 23 here. I'm going to just added a 0 and moved my decimal, but you get the idea. So it's 161 when I multiply those two. So I'll be taking 1/3 of 161. 161 divided by 3 isn't going to be perfect because if you add the digits 6, 7, and 8, 8 is not a multiple of 3. Therefore, I'm going to have a decimal, and that's okay. 3 goes not into 1, it goes into 16 5 times, which is 15. I get 11. 3 times 3 is 9. I get a 2, and I bring it down. 3 goes into 20. 6 times is 18. And this is an ugly repeater. Just keeps going on and on and on. I do need to go one more place because I am going to round to the tenths, and I look to the right, and I look at the 6. And it bumps that 6 up to a 7. So volume is going to be approximately 53 7/10 inches cubed. Okay, and so notice I had to round that to the tenths place. So the 6 looks to the right, sees a 6, and it makes the 6 become a 7. That's rounding rules. Okay, so that's our answer for that one. And we're going to move on to this shape here. And in this shape, if you notice the base shape down here is not a rectangle. It is a triangle, which means it's got one less face going around. The formula doesn't change. It's still going to be volume equals 1/3 big BH, but I need to understand that this is a triangular pyramid. And because it's a triangular pyramid, I'm going to have a little different base figure. So that big B there is going to be the base of which is a triangle. And I'm just putting a symbol that will help me. So I'm going to do 1/3, and the base is a triangle. So to find the area of a triangle, it's 1/2 little b little h, and then I have to multiply by h. And I know that looks strange. We have two heights. This is the height of the triangle. This one's the height of the whole shape where it's holding it up. Okay, and so this is the h of the whole shape there. But the triangle itself has a base and a height that's formed by the 90-degree angle right there. So I've got 1/3 1/2. The base of the triangle, you can either use 2 or 10. It doesn't matter which one you go. It's 10 and 2. And then the height of the whole entire thing is 9.6. And so I'm going to treat that a little bit separately just so you can see it. I can half either the 10 or the 2. It's completely up to you. I think if I half the 2, these both becomes 1s. That's kind of nice. So that leaves me 1/3 of 10 times 9 6/10. 9 plus 6 is 15. So I know 3 will divide into this number. So if I want to go ahead and just multiply 9.6 times 10, all that does is just moves the decimal one place to the right, a power of 10. So that's volume equals 1/3 of 96. So it's just multiplying 9 6/10 times 10, moves the decimal one place to the right. I get 96. So I'm going to take 96 and I'm going to divide it by 3. That's what taking a third means. 3 goes into 9 3 times, 3 goes into 6 twice. So my volume equals 32 kilometers cubed. Very easy, simple problem there. So again, back to you've got to make sure you apply your formulas. Make sure you know what the base figures are. Or is the base a triangle or is it rectangles? Okay, and it's based on looking for what side, and it's only got one base. What base is opposite the point where the triangles come together? So whatever the base is opposite. And if you'll get in the habit of shading in your base figure, it kind of helps you see the whole picture overall. Okay. Look forward to showing you guys volume some more. We'll see you next time.